All right, I'm just going to continue with examples. So I'm on to example number 5, and now this is perfect squares. So for example, x squared plus 6x plus 9. So for perfect squares, we have a bit of a checklist here. Perfect squares. So the first thing is there's got to be 3 terms. Okay. The second is that the first and last terms are perfect squares. That means you can take the square root of them, so the same as it was above with the previous example. And third, if you take the square root of the first and last, it adds to the middle term. Middle term. All right. So there are your 3 checks. So if we look at the first example here, we have our 3 terms. First and last terms, are they perfect squares? Well, x times x, so perfect square with a variable is if the exponent's even, so yes, so the same as it was above. Is the last term a perfect square? Yes, I can take the square root of 9, so that's good. And if the first and last term add to the middle, so maybe I need to clarify that a little bit. I should say first and last term adds to the middle, and then put comma after last term adds to the middle. Okay, that is a little bit, that's terribly worded, so let's fix that. We're just going to erase up to term here, and I apologize, I can hear you cursing. So square root of the first and last term multiplied together and then multiplied by 2. It's one of those things, it sounded right in my head, and then when I read it again, it's confusing as anything. So off to the side here, I'll show you the check here. So square root of the first and last term multiplied together. So the first term is just going to be x. Square root of 9 is 3, so we have 3x. And then if I multiply it by 2, we end up with 6x. And 6x is the middle term. So that being said, perfect squares are a single bracket with it being squared. You put the square root of the first term in the first spot. Let's put the square root of the second term in the second spot. So that's the 3. And whatever this sign here is the sign that goes in between. So it's going to be x plus 3 squared. All right. So a couple more examples with that, with those perfect squares. Let's go with do another one. So we'll go 9x squared, and then got 16 and plus 24x. So going through our check again, 3 terms. Are the first last term perfect squares? I can take the square root of 9, x squared, even exponent, so it's a squared, perfect square. 16, it's a perfect square. First and last terms. So this first term squared would be 3x. And I'm going to multiply it by the last term, which is square root of 16 is 4. So that gives me 12x. If I double that term, so I'm going to multiply it by 2, I get 24x. 24x and 24. So there's our perfect square. So again, it's going to be squared. First term is going to be a 3x. Last term is a 4. And it will be adding. All right. Another example. 9x squared minus 6x plus 1. All right. So first time you go through, it's the same old check. 9x squared, I just had it in the previous one, so it qualifies. There's 3 terms. Remember, you can take the square root of 1. It's just 1. So now we're on to the third one. So I take the square root of the first term, so that would be 3x, multiplied by the square root of the second term, which is a 1. So the result is 3x. If I take that answer, then 3x, and I double it, multiplied by 2, you end up with 6x, and I have 6x. So 9x squared, it would go down to 3x and a 1. The square root of 1 is 1, and it's all squared. And the symbol, whoops, that symbol there, use a different color, is what dictates the sign here. All right, one last example with that then. So for number 8, and this is what I'll throw out on the test on you, so just be aware of this. So 16x squared and minus 4 at the end. So that would be 8, 16, so plus 16x. All right. Now, when you go through the check, you got to be careful here because is this a perfect square? Take the square root of 16, yes. Even exponent, yes. Is this a perfect square? The sign is associated with it, and the answer is no, because square root of negative 4 for us is undefined. Okay? So therefore, it definitely does not factor, okay, as a perfect square. All right, so that will get you through the second component of the homework, and that is doing, or I guess that's the third component now, working with perfect squares and differences of squares. All right, moving along then, we can start into simple trinomials. So factoring simple trinomials, talked about this last year, and you saw this in the grade 10 course as well. So x squared plus 11x, and we'll go plus 30. So the process, and I'll do the long process first, and then you can shorten it up. So I know it's going to be a one-step answer, so equals, and I know there's going to be 2 sets of brackets with a simple trinomial. So underneath, what am I looking for? I'm looking for 2 things that will add to 11, so that's my middle term. I'm going to make a bit of a T-chart for myself, and it has to multiply to positive 30. So some people are going to pick this out right away, and you don't need to do what's in green, and it's the same with the previous stuff. Anything I did in green on the side here, so I need to stuff down the right side of my note. If you can do that in your head, you don't need to show it to me because it's already a known skill, so I don't need to see those extra steps. So it's the same thing here. So what multiplies to 30? 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, excuse me, and then I move on to 6, so I'm repeating myself. So do any of those, can I arrange any of those to add up to 11? And the answer is yes, right here. If I put 5 plus 6 together, we can get 11. So that means that because they're both going to be positive, because it's adding to positive 11, it's going to be plus 5 and a plus 6. And the nice thing with a simple trinomial, it's always x out front. All right. So let's do a couple more examples with the simple trinomials. And like I said, it's like riding a bike. You're going to get better with it. For those that were able to do it last year, it will come back. So don't panic. For those that struggled with this last year, you know, third time's a charm, right? So if you have any questions, though, this is where you got to get cleared up. So again, the extra chart, not necessary. Okay. So I know it has to add to negative 9. And I know it has to multiply to positive 20. So as a side note here, I know it's got to add to negative 9. So that means that I'm probably going to be dealing with 2 negative numbers. So let's figure out what multiplies to 20 first, then talk about that. So 1 times 20, 2 times 10, 3 doesn't work, 4 times 5, and then 5 times 4, so we're repeating ourselves. So is it possible to get any of those pairs to add to a negative 9? So 20 and 1 are definitely out. 2 and 10, that would give me either 12 or I could get it down to a -8, but I can't get it down to a -9. 4 and 5, I know 4 plus 5 is 9, so if I have -4 minus 5, it would work. Once you figure out the sign combination, those are the exact signs that get put in the brackets. All right, so once you figure it's -4 take away 5, it's going to be -4 minus 5 and -5 up in your solution. All right. I'll just do 2 more. Again, it's just a matter of getting you comfortable with that process. So x squared minus 7x minus 18. I know it's a simple trinomial. The reason I know it's a simple trinomial is because it's not common, it's not a difference of squares, it's not a perfect square. So this is the next one I'm trying. So again, it's got to add to -7. Okay. And it's going to multiply to -18. Now if it's going to multiply to -18, that means my two numbers are probably going to be different signs. So again, this is my adding, this is my multiplying. So what multiplies to 18? 1 times 18. And for those that can jump right to final answer, do so. You don't need to show this chart. 2 times 9, 3 times 6. 4 doesn't work, 5 doesn't work, 6 is repeating. So here we are. Can I get any of those to add up to -7? So 1 and 18, there's no prayer. 2 plus 9 would give me 11. 2 take away 9, that gives me -7. So if I had +2 and I subtract 9, it gives me -7. So this is the answer right here. And here are your signs. You've done all the hard work right there. You know it's going to be a +2, and you know it's going to be a -9, and it's going to be x and x. All right. The only other thing I want to show you that you could run into is an example that looks like this. So let's go through and we'll do 3x squared plus 15x minus 42. The first thing you try, always, is you try to see if there's a common factor, and that's what I'm going to do here. I'm going to see if there's a common factor with this particular question. So I look at the numbers. 3, 15, 42. Is there a number that will divide into each of those? And the answer is yes, a 3. There's not an x term in each term. Okay, that last term has no x, so there's x is not common. So I'm going to pull a 3 out. Excuse me. So I'm left with x squared plus 5x minus 42 divided by 3 via 1 is 14. So there we go. So it's a common factoring question first. Now, inside the brackets, it's a simple trinomial. So that means that I'm going to keep my 3, and I'm going to end up with 2 sets of brackets. And in those 2 sets of brackets, it's got to add to +5. That's my adding. And it's got to multiply to -14. What multiplies to -14? Well, let's just do 14. 1 and 14, 2 and 7, 3 doesn't work, 4 doesn't work, 5 doesn't, and so on. So there's only 2 choices. Can I get either of those to add to 5? And it's got to be positive. If I take +7 and I subtract 2, it would definitely work. Here are my signs. So I have x plus 7 and x minus 2. So there is going to be a series of questions near the end of the homework that involve you to do 2 steps. You're going to have to do common factor first, and then you're going to do simple trinomial. So there is your upper end simple trinomials this year. It's going to be a 2-step. All right. We should be able to finish the note in the next video. Good luck.